Hey guys, my name is Charlie, and in today's video I'm going to be showing why the centroid of a triangle lies 2/3 away from the vertex along a median. So to start this, I got Blender already opened, and I have made this triangle, this big triangle, and have already drawn the medians. And notice how the medians kind of separate this big triangle into 6 smaller triangles right here. To get started, we need to prove that the area of all of these 6 triangles right here are equal. Let's get started. So the first thing that I'm going to be doing is going to be drawing some altitudes. So let's go to edit mode, select this vertex, and we're just going to be extruding it to make an altitude for this bottom 2 triangles here, these 2 triangles right here. And notice, because this is a median, the length of this and the length of this must be equal. And because this is the height or the altitude of both of these triangles, therefore the area of the triangles will be equal, because the area of a triangle is 1/2 base times height, and if the base and height of the triangles are both equal, then the areas of the triangles will be equal. Okay, so let's drag them in like so. Now, the next thing that we could do is that we could do the same thing for these green triangles, or these 2 triangles right here. So let's draw our altitude. So extrude this vertex into an altitude. There we go. And once again, this is a median, so the length of this and the length of this will be equal. And they have the same height, which is right here, with the same altitude. So therefore, this green triangle and this green triangle have the same area. Next up, let's do the same for these red triangles. So extrude, altitude, there we go, and let's drag them in. And so therefore, these red triangles have the same area as each other, these yellow triangles have the same area as each other, and the green triangles have the same area as each other. Okay, well, let's move this away a bit. Okay, well, now let's clean this up a bit and delete some of our altitudes, because we won't be needing these anymore. There we go. We delete the edges. Okay. Now let's drag in half of our triangle back in. So drag in our 2 greens and a yellow. Okay. Now that we've proven that this triangle and this triangle have equal areas, this triangle and this triangle have equal areas too, and finally this triangle and this triangle have equal areas. Now it's time to prove that all of these triangles have equal areas. So let us first draw another altitude. So this altitude is actually going to be from this vertex at the very top, and we're just going to be extruding it downwards to the opposite edge, which is right here. And notice how this triangle right here and this triangle right here have like the same height or altitude, which is this, and also have the same base, because this is a median, and it basically means that this is equal to this, because this point right here is the midpoint along this line segment. Okay, so now let's drag in the other half of our triangle right there. Okay, now that we know that the area of this triangle right here is equal to the area of this triangle right here, because the base and height are the same for both of these triangles, now it is time to prove that all these triangles have the same area. So to do this, we notice that because these 3 triangles are equal in area to these 3 triangles, and how this is basically 2 green triangles plus 1 yellow triangle is going to be equal in area with 2 red triangles and 1 yellow triangle, we already have discussed before why the area of these 2 yellow triangles must be equal. So therefore, it's just going to be 2 green triangles will have the same area as these 2 red triangles. And therefore, the area of a green triangle is equal to the area of a red triangle. Okay, now we could do the same, but instead of this edge, we could use this edge instead, or this side of the triangle instead. So let's go to edit mode, and let's extrude this vertice so it makes an altitude. There we go, perfect. And once again, this is equal to this because this is a median, and this is the altitude for both of these triangles. So therefore, if we drag this back in, and these yellow triangles back in also, you notice that there is going to just be a green triangle plus 2 red triangles, and that will be equal in area to 2 yellow triangles and 1 green triangle. And once again, as we've discussed before, the area of this green triangle is equal to the area of this green triangle. So therefore, the area of 2 red triangles is equal to the area of 2 yellow triangles. And therefore, the area of 1 red triangle is equal to the area of 1 yellow triangle. Okay, now, we have proven that the area of a red triangle is equal to the area of a yellow triangle, and the area of a red triangle is also equal to the area of the green triangle. And this proves that all 6 of these triangles have the same area. Okay, well, let's move these out of the way now. And let us quickly fix this up by deleting our excess altitudes. There we go. Okay, now we're almost done, so let me quickly drink some orange juice because I'm getting thirsty. Okay. So, now, what we basically need to do is as simple as just extruding our median. Well, not extruding our median, but extending our median a bit. So, to do that, let us go to vertex select this vertex on the median, extrude it on the median a bit so that it is just going to be simply just a longer median. And then after that, we could also draw another altitude, but this time it's going to be from this point to this line segment right here. So let's do that right now. Select the vertex, there we go, altitude, and there we go. Okay, now let's drag in our green triangles, and let's drag in a yellow triangle too, because why not? Okay, notice that we have 2 green triangles which form a bigger triangle, and we also have 1 yellow triangle, and they share the same altitude. And notice how the area of 1 yellow triangle is going to be equal to the area of 1 green triangle, because the area of each of these triangles are going to be equal. And since there are 2 of these, therefore the area of these 2 green triangles will be 2 times as much as the area of this 1 yellow triangle. And since they share the same height or altitude, therefore the base of these 2 green triangles must be 2 times as long as the base of this yellow triangle. Because, once again, the area of these 2 triangles is 2 times as much, as 2 times as large as the area of this yellow triangle. And therefore, the length of this right here, this base of these 2 triangles, must be 2 times as long as the length of this base right here. And because of that, the centroid lies 2/3 away from the vertex of the triangle from the median of the median. Okay, so thank you for watching, and yeah, this is why the centroid of a triangle lies 2/3 away from the vertex along a median. Okay, well, if you want to see how I made these triangles, these kind of like colorful triangles, and this just general shape, and drew all these medians, and drew the centroid, click the video over here. I'm not good at this, but click the video over here. Okay, thank you for watching, and I'll see you guys next video. Bye!